we'll be discussing about probability control limits, and we'll be concluding about the discussion on control charts, both control charts for variables and the control charts for attributes. So what is meant by this probability control limits? All along, what is that we had discussed about them? All along, we were discussing about 3 sigma control limits. 3 sigma control limits. Mind that in the previous class itself, I have told you the control limits will be 3 sigma distance away from the mean. Okay. So we were talking about that one. That means we were expressing their values. But this probability limits means I want that so many values are, I should be 95% or 95%, 99% sure that whatever the process is going on, it is correct. And if there are any variations are there, they are due to the chance causes. Okay. So that one we fixed it at 3 sigma limit. In reality, in 3 sigma limit, about 99.73% we are confident that they will be falling within these 3 sigma limits. And our error, that means the type 1 error, would be hardly 0.27%. That is what we meant. Okay. Or we said totally it was the 2 limits whenever I fixed, the probability control limits were, one at the upper limit was the 3 sigma, that means it works out to something around 0.99865, and the lower control limit, it was something around 0.00135. So that in between these two, that means if I draw it, the upper probability control limit and the lower probability control limit, if I had mentioned over here and if I had referred the table, for example, I will show you on the table itself, that is normal table. You can see that with respect to plus 3, it is something around 0.99865. 0.99865, that is the area. The area between minus infinity to plus 3, if I refer this one, that area will be 0.9, that means this area from minus infinity, mind it, that area will be area between minus infinity to 3, because we are referring the normal table, standard normal table. Standard normal table means Z value, if you look at it, it will have 0 and its dispersion or its mean is 0 and its dispersion or the standard deviation, if we talk about, it is going to be 1. That is what we call it as, this is the standard normal table. Under these circumstances, area between minus infinity to 3 value of Z, this works out to be 0.99865 from minus infinity to this. And if we look at that means corresponding value for that area is for where Z is equal to 3. Okay, this value becomes 3. That means we have to be cautious about the sign also. It is not just 3, it is plus 3. And if I take under lower side, then the area between minus infinity to minus 3, it works out to be, if we refer the table, it works out to be 0.00 0.0135. Can you get this one? This area, it works out to from here to here, it works out to be, that is -3. What we are interested is the total area between -3, z value is -3 and z value is +3. That means this is the total area. If I want to find out the total area, that means it is this one minus this. It works out to be how much we can see. And if you add up both of things, it was ultimately it should work out to be the same, that is 1. So this total area works out to be 0.9973 or 99.73% of the values, they will fall within the limit -3 to +3. Then where is the 0? This is the 0 here. That is what we say, plus or minus 3 sigma limit. 99.73% of the values will fall. So we were finding out this ordinate. The ordinate corresponding to this 0.9973. There are two, because if we refer the normal table and if we want to end wherein the area under the normal curve, always it gives the probabilities. So the probabilities under any continuous curve, it has to be between two ordinates. That is why here I have taken two ordinates, one ordinate here minus infinity, it is inbuilt, that table, minus infinity to +3. Another ordinate minus infinity to -3. And now I am taking the two ordinates -3 to +3. What this one? So if we want that more than this it should fall, that means I want that 0.99865. If I say with the probability control limits 0.99865 and 0.00135. The person uses the probability control limits as 0.99865 and 0.00135, means nothing but plus or minus 3 sigma limits. That is what it means. We need to understand it carefully. Both means the same. That means with respect to this one, I am going to find out the value of z. With respect to another one, I will try to find out the value of z. So this fixes the lower limit and this fixes the upper limit. It is as simple as that. Because if it follows the normal distribution, if it follows the Poisson's distribution, and we will be finding out the values correspondingly. So both the things, let us see how it can be expressed. This is what I have given you, some gist about this. But how it is exactly applied to U chart and C chart, let us see. Why I am selecting this U chart and C chart is because of a particular reason. Because we know that U chart, it follows the normal distribution, whereas the C chart follows the Poisson distribution. Why C chart follows the Poisson distribution? Because its average value and standard deviation, so average value and the variance both are same. That is, the average value is C bar and the standard deviation and the variance is also C bar. Whereas in case of the U chart, its average value is U bar, but its variance is U bar by N. u bar divided by n, not u bar. Hence, it follows the normal distribution. So let us take up an example, and through example, let us see how we are going to address these probability control limits. Okay. So another example also I have solved with respect to the P chart, wherein we said that we want only 3 out of 1000, 3 should fall outside the control limits. It works out to be same thing as, that means 0.003 instead of 0.0027. It works out to be 0.00, that means 3 out of 1000. That is what it means. Try to understand. It means the same thing. But we need to be precise because we have to represent it in the form of upper limit and the lower limit. So these are the two probability control limits. So here if I look at it, plus or minus 3 sigma. That means both are also same. One is upper, another one is lower control limit. So in that way, it is not going to differ at all. Okay. With this one, okay, let us try to solve few examples on this aspect. Please take down a control chart for defects per unit. A control chart for defects per unit uses probability limits corresponding to probabilities of 0.975 and 0.025, corresponding to probabilities of 0.975 and 0.025. Full point. The central line on the control chart is at u prime is equal to 2. U bar or u prime is equal to 2. Full point. The limits vary with the value of n. Full point. Determine the correct position of these upper and lower control limits when n is equal to 5. Okay. That is why I have told you, because if you look at in general, because he uses the U chart, that is the defects per unit, U chart. So upper control limit of U chart, we know that it is equal to U bar plus 3 sigma U bar by N. Lower control limit U bar. Sorry, central line U bar. Lower control limit U bar minus 3 U bar by N. But when we are using this thing, when we are using 3 sigma control limits, in general, if I write this one, upper and lower control, these are the things, that is what you need to observe it cautiously. If I write it in general, then the upper control limit for U chart, I can write U bar plus Z under root U bar by N. Center line U bar. Lower control limit U bar minus Z under root U bar by N. Okay. I say 3 sigma control limit when Z is equal to 3 plus 3 here, and in this case Z is equal to minus 3. What this one? Minus Z. Z value is 3. If you look at it, Z value is 3. So this will take minus 3 because that is what I explained over here. So we need to find out only the value of the Z. If the Z value is found out, it works out to be correspondingly the same, because since it follows the normal distribution, it is bell shaped and it is equally distributed on either side. That is why one more observation you can make, even in this case or in this case, if you add up these two, it is going to be 1. If you add up these two also, it is going to be 1. Because the bell shaped and it has got the symmetry. So value of Z I need to find out. Whether you find out the value of Z for the upper limit or lower, it's the same thing, it is going to hold good. It is not going to change for lower, the Z value is different. For the upper, the Z value is different. No, in both the cases, it is going to be 3 only. And this sign, it will be taken care of over here. Because always when we use the standard normal table, its mean is 0. That is why we are going to use only one table, and the other things we are going to convert it to find out the Z. Now, if these basics are understood, then I can go ahead with this. Now, what he wants is, he wants this value he has given as 0.975. Upper limit value he has given, that he has given in, you have to find out the value in such a way that 97.5% of the items should fall within the upper control limit. The other way of what this one explaining, 97.5% of the values, they should fall within the upper control limit, and here 2.5% of the values, they should fall below, they should fall below the lower control limit. If so, what should be the value of Z? The question I am asking is other day, what he is asking is other way around. He wants that 97.5% of the values, they should fall below the upper control limit, and 2.5%, that is 0.025 is equal to 2.5%. 2.5% of the values, they should fall below the lower control limit. If so, what should be the upper control value and what should be the lower control value? That is all he is asking. Okay? Is it understood? So, what we need to do, and since pi has given n is equal to 5, because if you look at this one, it involves the term n here. That is why. Okay? So, we will try to, what we have to find out? We have to find out the value of Z from the table, substitute over here, because in that case, what are the known things? U bar, this one is given, N is given, Z is given indirectly in terms of those probabilities. So we are referring the normal distribution. Why? Because this U chart, it follows the normal distribution. Is it understood? So let us find out for the corresponding to the area 0.975, what is going to be the value of Z? Okay. So if we refer the table, because this area, it is varying, because it starts from minus 3.5 to plus 3.5. The total area they are given starting from minus infinity to that particular ordinate. Okay. Now it is the reverse way of finding the Z. So I need to locate where is this 0.975. 0.975, if I go on searching this one, I am going to get it under okay. I am going to get it under 1.96. What this one? The area I have to look at 0.975. Why 0.975? This is what he has given. 0.975. If you look at this, the 0.975, that is 1.96. So Z value corresponding to 0.975, the Z is equal to 1.96. So he is not using these 3 sigma limits. Try to understand. Instead of 3 sigma limits, he is using 1.96 sigma multiplied by sigma. This is what? Sigma is this. This is what it is going to be multiplied, not this, not 3 sigma limits. Try to understand. Okay? So Z value is 1.96. So U bar we know, this is plus, we'll leave it as it is. Z is 1.96 under this one. Here it is U bar minus 1.96. And since I told you, because both of these things, they are going to be, when they are added up, anything if you look at it, they are added up, they will make it 1. Or else you could have found out what is the area of that 0.025 and corresponding value of Z also. If you look at this one, here, this one also it gives under minus 1.96. That is what it gives. This also gives 0.025. If you refer this one, it gives 0.025 under minus 1.96. That means Z value here is 1.96. Is it understood? So he doesn't use 3 sigma control limits. He is using 1.96 control limits. Saying 1.96 control limits or the probability limits of 0.975 and 0.025 means the same. There is no difference at all. So if I substitute those values here, then the upper control limit, U bar, it is given as 2 plus 1.96 under root. U bar is 2 divided by N is 5. And this is, of course, 2. This is 2 minus 1.96 under root 2 by 5. Okay. This value, it works out to be 2 plus 1.239 okay, and this is 2 minus 1.239. So So this works out to be 3.239. Central line is 2, and this is something around 0.761. This is what we are going to get it. So saying this probability limit is same as these things. Because normal person, he may not be able to understand this. Only technical people can understand it. Statistical people, they can understand. But when it is going to be informed to the inspectors, you have to see this one. Find out that value. U-bar value or U value you find out. If it is varying between these two, yes, everything process is going very well. Or if there are any variations, they are due to only the chance causes. No abnormal causes are there, no assignable causes are there, so leave it as it is. But if it crosses, then you stop the process, try to investigate. Is it understood? This is how we'll be using the probability control limits for U chart. If you are not convinced, let us take some more examples. Similar, almost similar. You take down one more example. A control chart for the defects per unit uses the probability limits corresponding to the probabilities of I'll just wiped out. Corresponding to the probabilities of 0.95 and what should be the value I should use? Can I write 0.25, 0.025, 0.025? Which value I should write? I should write such a value that if they are added up, they will become 1. That means probabilities of 0.95 and 0.05. Okay, the Z value, then it remains same. Otherwise, it will not remain same. Okay. Probability corresponding to the probabilities of 0.95 and 0.05. Okay, that means 95% of the values, they should fall within the upper control limit. Okay, they should fall below the upper control limit, and 5% of the value they should fall below the lower control limit. If so, what should be the value of upper control limit and the lower control limit? We only need to experts. That's all it is. It boils down to that much of simplicity. Okay. Since he makes use of the U chart, again, we have to see he has to give U bar value and N value. At U is equal to 1, U bar is equal to 1.5, and with N is equal to 6, or sample size is equal to 6, determine the correct positions of upper control limit and lower control limit. That is what he has asked. He has given probabilities. What probabilities? He wants 95% of the value should fall below the upper control limit, and 5% of the values, they should fall below the lower control limit. If so, what should be the correct position of the upper control limit and lower control limit? That value we have to give, because he has expressed these things in probabilities. But when it is practically implemented, no, this will not work. We have to give it like that. This one, okay, in objective, yes, it is very well defined. I want 95%. 99% of the students should pass. Like that. I'll fix up. Or we say that 99% of the students or 95% of the students, they should get the value or the marks below this 99% of this thing. That is what 95% of the below the upper this thing marks I can give, and only 5% they should fail. If so, what is the upper control limit and the lower control limit? But there I need to give average value and standard deviation. Both of things are to be given. Try to understand. Here also, the standard deviation can be calculated only when U bar is given and N is given. Otherwise, I cannot calculate the standard deviation. Okay, whenever we are going to use the normal table, two things are to be given. One is the average value, another one is the standard deviation. If they are given, okay, fine, we can find it. So here those values are given and those probability limits are given. Yes, we can find it. Okay. So real crux, maybe in awarding the grade or whatever it is, whenever we will calculate those things, relative, these things, grading is done, we always fix this one. How many percent, what percent, that is to be fixed. No question about that. Okay. Or we can categorize how many I want them to be in first class range, how many I want them to be in excellent position, and how many, what percentage in the normal region, and the other group D or group E below that region. Okay, that is it all. That is what. So here again we have to calculate the value of that, means what? Corresponding to 95% values. If I am going to find out the value of Z, okay, fine. Our job is done. Okay. So let us find out that these things. What is the value of the corresponding limit of that? Okay. So if we look at the table, (95), okay, my dear students, here there is one problem. Because I look at plus 1.6 and I go for the area 0.95, but I don't get the area 0.95. I get the area either 0.9495 or 0.9505. What this one? So this is, it gives you some chance for learning how we should refer this table. That means I wanted exactly 0.95. I'm not getting. So interpolation will be done. Not extrapolation here. Interpolation. Two values, that means the value is between 1.64 and 1.65. Z value is between 1.64 and 1.65. So exact that value of 95% will be 1 point in between these two, that is 1.645. 1 point. So Z value, if I find out from the table, it works out Z is equal to 1.645. Okay. Even if you refer for this the same thing works out. Minus side, if I go 0.05, the same thing is going to work out there also. Okay? This is going to work out to be 0.0495 and 0.0505. So again, that is for 1.64 and 1.65. It falls between these things. So again, that is going to be so much. Hence, the Z value I am going to substitute over here. So this is already the U bar. It is given, the U bar, it is given as 1.5. 1.5 plus Z, instead of Z value, how much I have found out? I have found out 1.645. This is from the table. Okay, square root of 1.5 divided by 6. U bar is 1.5. This one is 1.5 plus 1.6, sorry, this is minus 1.645 under root 1.5 divided by 6. So if it is calculated, upper control limit, it works out to be 2.3225, 2.3225, center line 1.5, and the lower control limit, it works out to be 0.6775. These are the things. That is how it should be calculated. So you understand what is meant by probability control limits and how in reality they need to be transferred. Because when we can understand 3 sigma limit mod, Z value is 3. So here it is not probability control. The Z value is, depending on this thing, it goes on changing. Okay, that is all the difference. Okay. Okay, now we'll take up one more separate example. This is what we discussed about the normal distribution. Okay. Now, if we take up the Poisson's distribution, how it is going to work out? So let us create an example and try to find out the value for that. Okay. So if you look at that, find the 0.9, just take down, find the 0.95 and 0.05 probability limits for a C chart, for a C chart. Can you find out what I have said? Find the 0.9 and 0.05 probability limits for a C chart. Is it possible to find out? Or even normal this thing distribution, is it possible to find out? In normal distribution, you can find out the area, okay, fine. But again, the limits, if you have to express, then those values are to be given. That is what in the previous example he had given U bar and N. So, if it follows the Poisson, the C bar, that means if it follows the C chart, means it follows the Poisson distribution. If it follows the Poisson distribution, only one parameter is sufficient, that is average value. So he has to give. Okay. probability control limits, he has given 0.95 and 0.05. For a C chart, when C prime, now we have to tell, we have to specify, when C prime is 4.2, C prime is equal to 4.2. Yes, now I can find out. Mind it, it is not 3 sigma control limits. Okay, this is the probability control limits. So that means what? I need to find out for these two areas. What are those areas? He has given 0.95 and 0.05. Okay. So I will go to C prime 4.2. For which table I have to refer? G table I need to refer. So I go to 4.2. Okay. If I go to 4.2, now he has given under that one, for that C prime, he has given the total area, cumulative area. Now what is my maximum? This one is 0.95. So under 4.2, where I get 0.95, I should go. Now it is going to occur between see, if you observe it carefully, see, for C prime is equal to 4.2, upper limit he has given as the area will be under 7, it is 0.936. Under 8 defects, it is 0.972. That means 0.95 is between these two. What this one? You can say that it is something around 7.5. But expressing 7.5 defects, it is very difficult. Because same question could be asked, 4.2 he has given. Why not? Yes. Then, if 95% of the values with C prime is equal to 4.2, they should fall within the upper control limit, then actual upper control limit is going to be 7.5. Upper control limit is going to be 7.5. Okay? So try to understand. It gives directly. It gives direct value. No need to find out the other things. Okay? Have you understood? If you want to convert it into Z and then you have to find out, that is totally different. Okay? He has directly asked us, what is the upper control limit and the lower control limit? That means if I had written it, upper control limit for C chart as C bar plus, instead of C, some Z value, C bar. Now what has happened for us now, upper control limit, that itself we have found out to be 7.5. This is equal to 7.5. If so, and C bar is known, then I can find out the Z value. They have not asked that one. Try to understand. Where C bar, it is very simple. C chart, upper control limit, that means if the moment it crosses the 7 defects, then the process is out of control. If it is less than 7, process is under control. And what is the lower control limit? For that one, 0.05. For 4.2, under 0.05, we have to find out. So 0.05 occurs between 4.2 0.05, it occurs between 0 and 1. 0 and 1. Okay. Under 0 we can get 0.015. Under 1 we can, for corresponding 4.2, under 0 we get 0.015 area. And under 1, that is 0.078. That is something around 0.5. That is what we can say. That is something around 0.5. Lower control limit is 0.5. Okay. That is how it needs to be found out. Lower control limit, directly I can say that is equal to 0.5. And again, if the Z value, C bar minus Z into square root of this. So C bar, where C bar is equal to 4.2, that is what is given. Is it understood? If not, again we will take up one more problem. Let us keep this one same probability limits, but I change the value of the average value. Instead of 4.2, let us say it is C prime is equal to 9.5. Okay. For that one, we will try to find out. So again, we will go to the table where the 9.5 is there. So, okay, 9.5. Under that one, we will go on finding till I find 0.95. So, this 0.95 value for C prime is equal to 9.5. It is between 14 and 15 defects. Okay, 14 and 15 defects, because under 14 it gives 0.940 and under 15 it gives 0.967. So in between that one, if I consider approximately, so it gives me the value of 9 for 9.5, it is around 14.5. So upper control limit in that case, for this one, if I am going to calculate for C is equal to 9.5, the upper control limit is going to be 14.5, and the lower control limit we can find out as 0.004, that is between 2 and 3. .015, we want 0.5, is it not? So it works out to be 0.40, that is 4.089 under this thing. So that is, it works out to be 4.5. Lower control limit is 4.5. If the average value is changed from 4.2 to 9.5, upper control limit will become 14.5 and the lower control limit will become 4.5. And if it were 4.2, then it would have become 7.5 and 0.5 and 0.5. Is it understood now? We need not have to find out this Z value, not necessary, because we need to find out fraction distance. This ultimately we can make it the integer value. That means it is 14 and this is 4 for practical implications. That is 7 and 0. Right. That is what we mean. Okay, is it understood? Now, if it is understood, now I have got only less time. So only some 3 minutes to go. So, my dear students, we are discussing about the control charts, that is control charts for variables and control charts for attributes. And we have seen what are the various applications of control charts for variables and control charts for attributes. And in general, if these things are to be applied in a practical field, which chart is to be taken up first? Whether control chart for attributes or control chart for variables. And we know that after studying all these things, the control chart for attributes is to be first, because we need to find out the overall quality level. We need to find out if the overall quality level is good. We don't want to find out, the further investigation is not required at all. But if we need the further investigation, then we need to change over to the control chart for variables. Hence, in the industry, mostly the P chart is the starting point. Because these are going to be, the control charts are going to be one of the tools, 7 tools, which are being used. And after that one, we can see that Pareto analysis can be done. Because if we find out that the fraction defective, whatever is there, it is more than whatever is expected. Why it is increasing more? Because of what number of what type of defects? Okay? Because it boils down to that, what type of defects? Okay, then it makes us to think about, is there any different classification of the defects? Yes. They say A class defects, B class defects, C class defects, and D class defects. A class defects, they are very critical defects. So we are categorizing critical, because this might be asked as one of the short notes or something like that. A type defects, they are critical. That means it collapses the entire system. That is what we are talking about. In fact, the severity of the defects, which can be applied even in case of software industry. Because as most of the testing engineers, you need to understand this one. 2 things, severity and priority. In software, this thing, severity. So I don't have much time, otherwise I would have given certain talk on that. Severity and priority. This is the main job of the testing software engineer. And when it comes to manufacturing, we talk about these things. Critical. This is serious. Or we can say also major. C category, moderately serious. And D is minor. So we can identify these things. For this one, A critical means entire system is going to fail. Here, some parts of the system are working, functional. So priority first one, I have to give it to this. Next priority, I am going to give them. The moderately serious in the sense, in the future it is going to fail. That means maintenance will increase. It is consuming, because if I refer to the automobile, it starts consuming more petrol, more fuel, like that. Or its sound may not be good, or its speed is decreasing. Okay, the system has not failed, but there is a cause for worry about this one. Okay, but critical means it is not starting nothing, very major wrong in this. Minor means it is, as we say, some chance causes. So priority wise, it is to be looked into, but not as serious matter as this. Okay? Because when you sit before the computer, you are using certain software, it will not start at all. Nothing works. That is thing. Here, if I look at it, the minor. No, instead of when you are typing, instead of using the capital font. This one is small font. That is what has happened. So it is not that much of serious matter into the this. So this is because of the chance, something like that. Okay, that is how these things are to be classified and viewed. And when we got say, critical, that is critical, it is because of maybe for few things they have got the assignable causes. So then it suggests itself. It is almost just like Pareto analysis. Okay, we are putting it into 4 categories. That's all. So why this one more? Which one is more? Okay, that you attack. Why it is happening? That means in that case, it suggests that we should go for the control charts for variable. Otherwise, this one is sufficient. Okay. So with this one, I'll be concluding the session on this one. You need to understand, because you might have understood what is the difference between the control chart for variables and attributes, which one is to be used when. And again, within control chart for attributes, the difference between the U chart and C chart, P chart and NP.